of how to utilize the pH square. Um, and now today, what we're going to do is we're going to talk about neutralization reactions. Okay, it's going to be a little. I just got a few slides to show you. Got a little practice, and that's it for Friday. Um, and then next week we can hit some experiments about acid and bases. Okay, we'll do a titration. We'll probably do a neutralization reaction lab as well. Okay, but today we're getting the content. We're getting the background content today. Okay, so what I'm going to do, I'm going to present my screen real quick so you guys can see what I'm seeing, and then we'll be good to go. Okay, you don't have to take notes today, but it might help to write down a few things, just possibly. Okay. All right. So neutralization. All right. Now, the key word here is neutral. There's one substance that we know that is a guaranteed neutral, and that's water, right? So whenever we're talking about a neutralization reaction, that's water. We're talking about something that creates water. Okay. And so this is the definition of a neutralization reaction. It occurs when an acid reacts with a base and it creates water and a salt. Okay. So acid and a base creates water and a salt. And that's actually, if you know that, you're going to be golden for today. I'm actually going to write that down myself. Okay. Now, in a neutralization reaction, hopefully you guys remember our 5 reaction types, right? We had combustion, decomposition, synthesis, single replacement, and double replacement. Well, a neutralization is a double replacement. Okay, that means we have a compound plus a compound. Creates 2 new compounds, right? So it's a double replacement reaction. All right, so that's neutralization. All right, that's what we're kind of focusing on. Now, we create a water and a salt. So in chemistry, a salt is known as a chemical compound consisting of ionic assembly cations and anions. That's a big definition. All right. So as if you have a positively charged and a negatively charged ion, that creates a salt. So really, when we hear salt, we think of something you put on food. However, salt is so much more than that. All right, salt can have baking soda as a salt. Silver iodide that can be used in photography. Chalk is a form of salt. All right, there's so many different calcium chloride that's used on roads, right? So many different types of salts. Now we're gonna practice. All right. Now, got to put on our thinking caps a little bit. All right. So if we check out this equation, I'm gonna bring this over. If we check out this equation, we have HF plus KOH creates. Now, we always know one of the products. What's one of the products has to be in a neutralization? Well, it has to be water. One of the products always has to be water. Now, if we look at this, H2O, that means in the reactant side, I have to get rid of two H's. Because I have two H's right there. I have to get rid of, there's one H, there's a second H, and I have to get rid of an O. That leaves two elements left as a second product. Now, this is kind of very beneficial. Any element on the left-hand side of the periodic table, which are metals, I'm going to put that left, which are metals, are positive, and they will go first. Okay. All right. And then any elements on the right of the periodic table are called nonmetals, right? Hopefully we remember that. Those are negative. They're going to go second. Okay, so if we check this out, I have water plus, what's going to come first? First is going to be an element on the left. So is fluorine or potassium on the left of the periodic table? Hopefully you saw a K in the first column. So K is going to represent the first element. What's going to go second is elements on the right, and hopefully you see fluorine at the top of column 17. And that's our answer. KF equals water. So you just predicted products of a neutralization reaction. Okay. You just predicted those products. How cool is that? All right. So let's try another one. Okay. Let's try another one. Let's write it out. So we have HBr plus LiOH yields. All right, let's see. Well, I always know one of my products, right? One of my products is always water. So that gets rid of H, H, and an O. What's my second product going to be? Somebody can unmute themselves. What's the second product going to be? Well, out of these two elements, one of them is on the left of the periodic table, and that one will go first. The other is on the right, and that will go second. Well, hopefully you saw element number 3, lithium. That's on the left, so that will go first. Lithium will go first, which means bromine will go second, and that's your answer. Does that kind of make sense, guys? So just think, do I have one more? Nope. All right, so hopefully that kind of makes sense on that. All right, predicting products. All right, one of the products is always water. Now, what if we have to work backwards? What if we have to work backwards? Now, this is where it gets a little tricky, but I think we're going to crush this. All right, so working backwards, we have to determine the acid and base that were used to create the water and the salt. So for example, if we start with KBr, okay, I'm gonna flip this around. If we start with finish with KBr, okay, if we're working backwards, we know a product is KBr. What is another product? Always a product of a neutralization reaction. Well, product is always water. Product is always water, right? So when we're working backwards, we have to find out what is the acid and what is the base. That's our goal. What is the acid? What is the base? So let's think 2 days, Thursday, Wednesday, Tuesday, when we were talking about acid and bases, or maybe Monday, Tuesday, yeah, Tuesday. When we were talking about acid and bases, we said acids always start with an H. Acids always start with an H, and bases always end in an OH. That will always occur. Acids will always start with an H. Bases will always end in an OH. So if you look, that's my H2O right there. I'm done with that part. Now, KBr. Remember, any element that's to the left is positive. So that's going to be positive, which means my bromine is negatively charged. Okay, that's what we just talked about, right? Any element on the left is positive, bromine on the right is negative. Now, we know that acids start with an H. So I'm going to zoom in on this. So we know we have to put something here, right? And then there's going to be plus, and we know something's going to go there. Now, when we're looking at this, H comes first, right? So that means H has a plus positive. Any element that comes first is positive, just like over here, K is positive, which means Br was negative. That means my OH is negative. So I know that's what I know. Now, what you got to do is you got to think of a magnet. Okay? Think of a magnet. All right? If you're trying to put two pieces of a magnet together, let's say here's my magnet. This is a positively charged, that's negatively charged. Should I put a positive charge to the side or a negative charge? Do opposites attract or do opposites repel? Opposites attract, right? So if you have a positive, you want a negative. So it's the same thing up here. If I have a positive H, this second part has to be a negative. So the only negative I have left is Br. And if this is a negative, it has to start with a positive. The positive I have is a K. So my K is going to go there. So if we look at this, positive, negative, and over here I started with a positive, I end with a negative. All right? Because going back to our previous example, elements on the left are positive. Elements on the left are positive. Elements on the right are negative. Okay? So let's try another example. I think we're starting to get the hang of it. CsCl. I want you guys to try this one out. CsCl. What is the acid and what is the base? Take a minute, try to get this. Okay, so let's try this out. Hopefully you got decently far. So I know a product is CsCl. I know a product is CsCl. My other product is always water. All right, so predicting the acid and the base. Well, I know acids always start with an H, right? I need a positive here and a negative there. Positive. What do bases always end with? Well, bases always end with an OH, right? So that takes care of my water. Remember, start with a positive, end with a negative. So here I have to put in my negative. Well, the only negative I have left is Cl. And the only positive I have left is Cs. And there is your acid and base. HCl, CSOH. Okay. Is there any questions on that? Any questions on that? All right, to finish off, now, are these reactions always going to be neutral? In a neutralization reaction, are they always going to be neutral? No. The answer is no. Okay. And the reason why is this chart right here. Okay. The reason why is this chart, and this chart might be something good to write down. Okay. So if you have a strong acid on the left, a strong base on the right, those are going to neutralize each other. However, if you have a strong acid and just a weak base, just some weak, well, you're going to have an acid. All right. But if you have a weak acid and a strong base, well, it's going to be base. Okay. What if you have a weak acid and a weak base? What if they're both weak? That would also be neutral. That would also be neutral. You guys need more time on the slide? Are we good? Sweet. All right. That is it. We're not predicting these today. I'll go over different types of strong and weak bases when we come back. All right. So for today,